In this video, I'll be showing how we can solve for the root of a function using bisection method. This is section 1.2.3 of the textbook. And the idea is, imagine we have an interval a and b, and our function looks like this curved line. And we want to find the root of this function, which is exactly this point where the function hits the x-axis. In other words, where f of x is 0. So you want to find this point using numerical technique. So we're going to start with two guess points, a and b. A and b are not the solutions. These are just the guess points that we think can sandwich this, the solution. So the solution is this point, and a is, let's say, on the left side and b is on the right side, such that this is f of b, and this is f of a, right? This height is f of a, and this height is f of b. So if I multiply these two, I get negative, because this is positive, this is negative, so then if I multiply fa by fb, I get negative. If fa times fb is negative, that means the root has to be between a and b. I think this is intuitive, because if a is negative and b is positive, somewhere in between the function should hit 0. Otherwise it cannot jump from a negative to a positive value. Alright, so that's the condition we're going to check. If fa times fb is negative, then the root has to be between a and b, where a and b are just the initial guess points. How we can get these guess points? There's no way actually to find them. You have to only guess them. And let's say if you guess fa and fb, or maybe a and b, if you guess a and b such that fa times fb is not negative, that means that the guesses are bad. You have to change the guesses. You have to change until, keep changing until fa times fb becomes negative. So here's the algorithm. You're going to guess a and b such that fa times fb is negative. If this is not true, we have to iterate over a and b until we get some a and b such that this holds. Alright, then we're going to find the average of a and b. You call it c. Then we're going to check if fc times fa is positive. And we're going to replace a, our first guess point. We're going to replace a by c. Otherwise, we're going to replace b by c. So this is the condition we're going to iterate over until a and b become equal. So you know that in this line, we are dynamically changing a and b. We're replacing them by c. So at some point, a and b become equal. And that's the point where we have to stop and declare c, which is the average of a and b, to be the root. Of course, if a and b are equal, then c, which is the average of a and b, is also equal to a or b, and that's going to be the root. So as a specific example, we're going to look at equation of state, random equation of state, which we looked at in the last class. And we're going to see how we can solve the root of this function using bisection method. So these are the constants. R is a gas constant, pressure, temperature, A and B are two other constants. And we want to find for which V this equality holds. Alright, given P, A, R, and T. Alright, so we're going to start with two guess points. Let's say I guess 5 and 3. I'm going to check whether these guess points are fine. So I calculate f of a. So what is f of a? I just implement this equation into the cell exactly by addressing the cell location. I calculate f of b. So here's f of b. You can see how it's related to these coefficients. Given this is b, then I find c, which is the average of, you see that here, blue and green, average of these two is going to this cell. And this is f of c. So if this is c, you can calculate f of c. Alright. So what is next? Let me erase. In fact, I'm going to erase these. Alright, now I'm going to calculate f of a. I'm sorry. Now we're going to check. So for this cell, we're going to check this condition. If fc times fa is bigger than 0. So look at that. There's an if condition here in Excel you can use. you start by equality sign, so equals, and then you type if, then open parenthesis, if f10 times c10 bigger than 0. Let's see, f10 is this, c10 is this. If this times this, if this times this is negative, positive, then we have to replace a. But because this is negative, right, this times that is negative, you're going to replace b by c. So a is going to be intact, and you see that b now is replaced by c. So this is our old c. Now here we're going to replace b by c. So c used to be 3, now it's 4 because it's replaced by c. But how we can do this in Excel? So the first condition we had was if fa times fc is positive, then we're going to replace. So in if statement, you just write comma, and then if this condition is true, we're going to replace it by the next argument, which is E10. That is C. And if this condition doesn't hold, then we're going to replace that cell, this cell, by A10, which is the cell itself. This is A10. So that means we don't do anything. In other words, if this is positive, we're going to replace it by C. Otherwise, we do nothing. Okay? You can see that as soon as I click on that, Excel actually writes the general form of an if statement in Excel. So in if statement, you have an if and in parentheses, three arguments. The first one is the logical condition we're going to check. If the condition holds, then the second argument will be used. And if the condition does not hold, then we're going to use the third argument. All right. We're going to do the same thing for B. You say if fb times fc is positive, then we're going to replace b by c. So the second argument again is c, which is E10, right? E10. And then otherwise we're going to keep b, which is B10, the previous b value, right? The one above. These two conditions together would be equivalent to if fc times fa bigger than 0, we're going to replace a by c, otherwise we're going to replace b by c, right? So this otherwise thing is reflected by two if statements for these two cells. All right, what is next? And you're going to grab these two cells, hover mouse on the lower right corner, drag down, then you get equations for these two. By the way, make sure in the first line the equation has this freezing $ symbol, not to change the numerical index of the constants. Well, I think the first $ are actually not needed. You only need the $ behind the numerical index. I'm going to get rid of these to avoid confusion. B, it should be B. Fine. I'll move this. Oh, actually no, that is fine. I'm going to keep it. The reason we put $ here because as soon as you write the equation for this cell, you can actually drag it to the right. And if you also freeze the letter index by moving from left to right, Excel doesn't change the constants. So in Excel, as soon as you drag, every time you drag something from left to right or right to left, in other words, if you drag sideways, then the letter index will change automatically. If you drag up down, then the numerical index is going to change. And so since we write the equation here, I'm going to just drag it over to the right cell to have the equation for f of b. Then we're going to freeze also the letter index for the constant such that if you drag this, the letter index, doesn't change. Anyway, so then we're going to highlight these two just to drag down. FC, just drag down. And then f of c also drag down. So basically drag down these four cells. All right, what is next? I'm going to highlight all this and just drag it down until you see that A and B become equal. So, well, A, we are getting closer, starting from 5.3. Now we're getting close to 4.2 and 4.2, but they're not equal up to 3 digits. So I'm going to go down one more step, and there you go. So up to 3 digits, they're equal. So this is going to be the root. And as a sanity check, the c, which is the average of these two, exactly equal to a and b, and the f of c, which we claim is the root, is going to be 0, and you see that it is 0. So f of c is 0, c is the root, average of a and b, the stopping condition holds when a and b are equal. So I hope this is clear. This was bisection method to solve for the root of a function using if statement in spreadsheet. Thanks for watching, and stay tuned for the next section on Newton's method to solve root of a function.